visit. Yes.
Okay, once again, a warm welcome to our mathematics education seminar organized by the Freudenthal Institute. We are very happy and honored to welcome our speaker of today, which is Filip Moons from the University of Antwerp, who will report on his PhD thesis research. And I'm not going to speak any longer. The word is all yours, Filip.
Okay, so good afternoon, everyone. So I'm going to speak about atomic reusable feedback, a semi-automated solution for assessing handwritten mathematics tasks. So first of all, did you know that 49% of the teachers in the European Union actually complain about having too many correction or grading tasks? It's also the second biggest complaint in the whole European Union for all teachers, not especially mathematics teachers. It comes right after having too many administrative tasks to do in the teaching profession, but this one is the second biggest complaint. And then if we look to mathematics, then some things can be highlighted. First of all, we know from a lot of research papers that students often lack feedback in math class. We do highlight mistakes at best, but really providing feedback, we don't do that so much. It's also something our inspectorate always says, that teachers don't give enough feedback. But also there are systematic error patterns in mathematics. Multiple students, although they didn't cooperate, will make the same mistakes because there are certain misconceptions that are also well described in the literature. So you will always have the situation that the same mistake appears over and over again. And then, as a last thing, of course, you can improve the time investment of assessment by uh, doing digital assessments, but we know there are some validity problems. You cannot really assess all required mathematical skills through digital assessments. Also, it's not always very handy for students to type in their answers. So what I try to do in my whole PhD thesis is taking another approach, namely you have pen and paper assessment. I will call and refer to it as PP in the rest of the presentation. So a student takes a test or an exam or a task just by writing on a sheet of paper. And then at the other end, you have fully automated assessment where the tests are digital. And what I ask myself during 3 years from now is, can we bridge the gap between the two? And that's what I call semi-automated assessment. The idea is very simple. For some questions of an exam, for example, it's still necessary that students write on a sheet of paper because it's much more natural for them to express themselves mathematically by writing on a sheet of paper. But the assessment by the teacher is through the computer, or at least with the help of the computer. And I will present today two studies that are actually examples of semi-automated assessment. The first study is about semi-automated assessment for individual teacher. It's actually a tool to help teachers to give feedback to mathematics tasks or science tasks. It's definitely it's definitely an approach that also works for other subjects than mathematics. Now, I give you this example, very easy question. Yeah, the question itself is easy formulated, maybe not so easy for students. Manipulate the following formula, and then you see a student answer. If you want to give feedback on what a student is doing here, it's a she's doing all kinds of weird stuff, you probably end up with a very long text describing all the things that are wrong with this student solution. For example, mind the fact that dominant operation in the right-hand side of the equation is addition, and then a whole text. Now, remember from one of my first slides is that lots of students will make the same mistakes. And the whole idea of the first study is that I want to recycle feedback. So teachers give feedback, the computer saves it so that we can recycle the feedback. But if you look at this text, I think you all agree this is not really be likely to you will not be able to recycle this text very easily. So the first thing I was thinking of, can we change the way we give feedback to make it more reusable when other students make the same or a similar mistake? And that's the whole idea behind atomic feedback. So instead of writing a long text with everything very specified to a student solution with everything that's wrong with that solution, I have some guidelines to say, and I will show them in the next slide, split it up and make a list of it. The list can be hierarchical. That's very important. So you can cluster sub items under one main item by making the list hierarchical. And if you, I'm not going, I only have 1 hour to speak, so I'm not going to make the whole comparison. But if you look to the classic feedback and the atomic feedback, and you really read it, you will see that the atomic feedback says exactly the same, but in a much more structured way, and also it's separated. So all the items that are in the feedback are separated. And that's the whole idea about atomic feedback. If you want to write it as a teacher, and you now should be very careful, because in 2 minutes it's up to you to write some atomic feedback. You should firstly identify the independent errors that occur in a student's solution. You should write items for each error separately. So that's exactly what happens here. The dominant operation was a mistake in the first step. The final answer was apparently right, but some things were wrong with it. And if you see a structural mistake or misconception, for example, starting with the wrong dominant operation, you should state that and then add sub-items to it to explain what really concretely went wrong in the student's answer. So you can have some general statements like dominant operation on the right-hand side is an addition, and then you can make it more concrete for the student what you mean by it. And the whole idea is to break down feedback in an hierarchical list of feedback items, that it's much more reusable when another student makes similar mistakes, because you can reuse parts of it. That's the whole idea. I don't know if there are already questions about that. And I give also an example here, a mistake when making the denominators the same. That's a structural mistake. Lots of students will make this mistake, and then you say where it exactly happened in the student's solution. So it's immediately up to you. I will put the address in the chat. If you go to it, I will log out. So then you will see this screen. So I invite you all to go to, it's no link, that's inconvenient. I will rewrite it as a link, then you shouldn't copy paste too much. Yeah, now it's a clickable link in the chat. And then you see this screen, you log in, the username is university, and the password is Utrecht with a start with a capital letter, exclamation mark 123. And then you have this.
It works.
That's always nice to have a confirmation like that. Then you click on Mathematics Education Seminar, and then you will have this screen. And I will give the demo of study 1 at the moment. So you click on task on linear equations. Then you have this screen, and then you can start to grade. It's in Dutch, but don't let that spoil the fun. I will just quickly show how the system works. So
could you please repeat the login data?
It's in the chat. So
University, thanks. Yep.
University as a username and Utrecht exclamation mark 123 as a password.
Sorry, Philip, I can't read this. Is it okay if I don't grade?
Yeah, of course, but then you will have 5 minutes in silent, I'm afraid, but it's no
Okay.
problem if you cannot take part to the demo.
Rag
So
means question, I guess.
what?
Rag means questions, I guess.
Yeah, but I will explain the system. So if you can look
Okay.
for a moment, and then you can try it yourself. So yeah, one of the things we use this system in an experiment where we also registered the time of the grading time for each question separately. So you'll always have to start with correction, and then you see the first question is very easy, solve the following equation. And then you can say, okay, I want to write atomic feedback for it. I want to say, oh no, this is absolutely perfect. Or you want to say, this is not answered. So I will write atomic feedback, and then immediately a list starts where I can say something. And then I will say something like, I just give an example. You can also grade it. There are some shortcuts for it. If I now, for example, tap on the plus on my keyboard, then he will add grades to the students. For example, +5 or -5, it's all possible. Then if you type backspace, you can have the following item. And if you want to make it a sub item, you have to click on tab. I will show on the slide all the shortcuts you need to use the system. I will just say something here. It doesn't really belong to this solution, but mine is okay. Then the system calculated the score. So 5 minus 2 is 3. And then you always have to say that you want to stop, because now the time is registered, and then you can go to the second question. I will just say it's perfect. And the third question, I will also say it's perfect. If I then click to save and show next, I go to the following student. It says everything is saved. And then if I want to write atomic feedback again, I can reuse the items I already expressed for past students. And that's how the system works. If you have questions, please ask them, and I will go back to my slides. I will give you 5 minutes to experiment with it. What's important, because I didn't know beforehand how many participants we would have. You all logged in with the same credentials. So you will see all the items the others also saved. So normally a teacher in the experiment only saw the items he wrote himself. Yeah, I couldn't do that because you are all locked in as University of Utrecht at the moment. So these are the shortcuts you might need. And if you have questions, please ask them. And otherwise, I'll give you 5 minutes to experiment with the system. Anna, are you happy or?
I have a very small question. Why
Please.
this feedback is called atomic?
Because you split it in separate items. Atoms, yes, atomic items. Yeah.
Okay, thanks.
Also itemic feedback instead of atomic, but that's a joke. The serious question is, what happened to the hierarchy?
Oh, you can make a hierarchy by pressing tab, then you indent the list. So if you write an item and then you click on the tab button, so this button.
Yeah, I see it now. I see the indent. Okay. Yeah.
And then it indents. And to dedent, you have to go backspace.
Let's see.
So try it, get the grasp of it, and I will start talking again in 4 minutes. And if you have questions, please ask.
I pressed reset. Did I reset everything for everyone?
Oh, don't. It's this me no, just experiment. It doesn't matter really. The items will be saved. If someone saves an item, the items will be saved. This means that the teacher will need to mark many answers to generate various feedback. That's absolutely true, Mariam, indeed. Yeah, what Janka says is actually something we also noticed in our experiment, that some teachers sometimes do it unconsciously by keeping track of comments in a Word file and copy paste them.
When you have to grade like 100 or 150 solutions of the same problem, and you like after 15 or 16 students, you get the same issues. So this is really convenient form. I really like it. And Filip, I might contact you after this how to implement it in our Moodle.
Okay, perfect.
It's great. Hi, Eva.
Well, I give you 2 more minutes. So write your last sentence, and in 1 minute, I'll start talking again. Okay, I will start talking again. If you want to try, if you can't get enough, it's no problem. The account will be active for forever now. So tonight before going to bed, you can still try the system. It's no problem. Of course, we did an experiment with this system. Also, we categorized all the items the teachers have expressed in atomic and non-atomic, and by using a code book. Actually, I wanted to give an example of something you wrote and say it's atomic or not, but I saw very general statements like distribution law and stuff like that. I think everything that was written today is considered as atomic, but it took us quite some iterations to come up with a complete code book to really say that's atomic, that's not atomic. So actually what we did is we compared this system with the classic system of giving feedback, actually by the teacher write, the whole idea is that the teacher write that feedback by writing on a sheet of paper. We did a pre-study where teachers effectively did write their feedback in the classic feedback condition on a sheet of paper, but then it became apparent that we were actually measuring if teachers are more speedy in writing on a computer or by writing on a sheet of paper. So we changed that condition, and in the classic feedback condition, they just wrote a text without the system. That was the whole idea. And so we had some research question, of course, how did teachers perceive the system? We wanted to solve, the whole idea is to make life of teachers easier. So is there a time difference between using this system and classic and just write classic feedback without the system? Then we did the whole codebook thing. We also asked ourselves, is atomic feedback, the whole idea of writing feedback in an atomic way is, of course, that it can be reused much more. So it was, of course, a research question. And also a very important research question is, was the feedback given in both conditions different? I'll quickly guide you through the results. So you saw some examples of 3 students of the 60 students we sampled. So we sampled 60 student tasks on linear equations. The task consisted of 3 questions, 1 easy procedural question, just solve the equation, 1 manipulate a formula, and 1 word problem. So a very classic task on linear equations. And then we invited teachers in the summer of 2020. It was in the middle of the COVID pandemic, where they came one summer day to our university to assess those 60 tasks in 2 conditions. So in 30 random students were assessed by them with the atomic feedback system, and the other 30 they had to write classic feedback. The both conditions were balanced in that sense that the 30 students in each condition were 10 good students, 10 moderate students, and 10 bad students, so that it couldn't be that one condition was much harder to assess than the other. That was balanced. And also every student appeared exactly the same time, exactly the same amount of time in the atomic feedback condition and in the classic feedback condition. And if we see how the teachers perceived it, we used the technology acceptance model with a very high result. These results are on a 7-point Likert scale, so it's quite high. The only thing is that the perceived ease of use is a bit lower than the rest of the scales. And what teachers said, but almost all of them said, I really like the system, but I tend to forget how I formulated some items. So if you did the demo, you probably see that the system only tries to match what you are typing with items that are already in the database. And a lot of teachers said, yeah, this actually doesn't work for me. I know I have an item somewhere that's going that is about this mistake, but I don't know actually how I formulated that anymore. So making the suggestion system much smarter by using recommendation systems and stuff like that is one of the open research questions still under current consideration. Then, although my whole goal of my PhD is reducing the time teachers need to assess and definitely to give feedback to math tasks, I failed in that quite miserably. So here you see the amount of tasks that a teacher has assessed in one condition, so 1 to 30, and then the time they need. And if you look at both graphs, so the red graph is the semi-automated system with atomic feedback. It starts high and then drops. The classic feedback condition starts a bit lower, but then drops as well. Actually, there is no significant time difference between both conditions. The teacher spent an almost equally amount of time in both conditions. And you see that after a while, teachers are so used to assess a certain task that the time drops by itself. It's not because the system, it's just because teachers have seen it all and can go very quickly. But it's not so negative, the story. They used the time to write significantly more feedback in the atomic feedback condition. And the coherence D is 0.4, which is a medium-sized coherence D. It's quite high. So a lot more feedback characters were registered in the atomic feedback condition than in the classic feedback condition. So they actually didn't save time, but they used their time to give more feedback. That's what this is about. Then, yeah, we also analyzed all the items in the atomic feedback conditions that the teachers wrote. And if we talk about violation of atomic feedback, is that a lot of teachers actually needed to point out where a mistake happened. That was also a comment during the experiment that appeared a lot of time, that they say, I want to point where the mistake really occurs and there and give my feedback there, because a lot of the items contained the location. For example, in the second step, you made a sign error, for example, but that makes the item non-atomic because you should split second step and sign error, because a sign error can also, of course, appear in other steps. So to make it more reusable, you should split that to really write your feedback in a very atomic way. And then, of course, the second violation is no surprise that the atomic feedback item is just not atomic because it addresses multiple mistakes at the same time. Then a very positive result. So we classified with 2 coders after some iteration all the items in atomic and non-atomic. So atomic and non-atomic according to our codebook. And then we looked, are these items reused, yes or no? And reused is just used more for more than one student. That's the definition of reused. And then we did the chi-square test of independence. And then we could prove that effectively atomic items that were labeled by us as being atomic were significantly more reused than non-atomic items. So we actually invented now some guidelines that make feedback more reusable than non-atomic feedback. And it's an odds ratio of 2.6, which is not so bad. And actually, all these results that I explained are already published in one paper. Then the next step, and that's something we're still doing, is looking at, okay, all these teachers have given feedback in 2 conditions. Are there differences between these 2 conditions? We already know that teachers gave more feedback in the atomic feedback condition, but are there some other differences to see? Yeah, you will probably know. That's a very good question of Michiel. Is the feedback supposed to warrant grading or for learning by the students? And Rogier also asks a very good question. How is the feedback perceived by students? So to ask the question of Michiel, actually, all the teachers were instructed to give feedback for learning. The whole grading was actually said multiple times during the experiment that that was not the goal, but just to see if we could do something with that data as well. And the perception of atomic feedback by students was not considered in this study, but will be in the second study I also will shortly present today. But that's still an open question. And definitely where I think this can be really useful in classroom settings is, for example, you gave a lesson, you give an exit ticket to students, you assemble all the exit tickets and you quickly grade them by using atomic feedback and you're using your feedback, and then to see if students can improve their answer. I think that's some study I still want to undertake to really see if they like it and also if they understand it more than classic feedback. But it's something we didn't investigate at the moment. Can students give feedback to each other is also something that would be a nice thing to investigate, but we didn't do it for the moment. Definitely the second study would also be perfect for peer assessment, but more on that later on.
Let me just do my moderating statement. It's nice to have this quick interaction, but I think we should let Filip to run further, asking only clarifying questions in the chat. Yeah.
Okay, so keep all
But
your...
these are all very nice questions. Let's come back to them.
Perfect. So as a first step to see if the feedback differed between both conditions, we use text mining. You will notice that I'm quite statistical in my scientific approaches. Of course, I also wanted to try text mining. So actually how it works, you have all the feedback. The first thing you should do is remove all stop words like in English or D or some, all these words don't really mean something, so you remove it. Of course, the feedback was written in Dutch. Then we perform the analysis, and all the graphs I will show you are translated automatically by DeepL. And one of the first things you normally investigate when comparing two bodies of text is the word frequency. So all the words close to the identity line are words that are used more or less in the same amount of in the same frequency in the classic feedback condition and the atomic feedback condition. For example, operations was used almost the same amount of time in classic feedback as well in atomic feedback, but there are X is also heavily used in both conditions. But for example, perfect appeared way more in atomic feedback than in classic feedback. Super and beautiful appeared way more in classic feedback. This is, of course, very logical by the design of the system because perfect was an option you could click immediately. So a lot of teachers just, when the answer was completely correct, used the button perfect and didn't use other words. That's one of the reasons why perfect is much more popular in atomic feedback. But in general, the correlation was very high between the words, 0.9 almost. So actually, but of course, it's are the same teachers, but they use the same wording to phrase their feedback. So I will make a bag of similarities and differences of both feedback methods now. So the word usage was more or less the same. Appreciation words, I just explained that perfect was used much more in atomic feedback. And then abbreviations appeared way more in classic feedback. For example, OPL, VD, it's our all Dutch abbreviation that, of course, DeepL failed to translate. OPL is actually a solution, abbreviation for oplossing in Dutch, so solution, VD, of die. So you see a lot of more abbreviations appearing in classic feedback than in atomic feedback. So teachers, yeah, because they could reuse it, they took the time to write words more in full. So another difference. We also looked the amount of words spent on very good answers. So with a grade that's the reason why we needed the grades with a grade 7 or more, between 5 and 7 or less than 5. But there we see that actually almost the same amount of feedback was spent on good, moderate, and bad answers in both conditions. So that's a kind of similarity. We also did a cluster analysis. What you see here is actually how words appeared next to each other. For example, both sides of are 3 words that appeared frequently next to each other. Wrong transition and stuff like that. What you see if you compare the graph of atomic feedback with the graph of classic feedback, that the graph of atomic feedback is much more interconnected than the graph of classic feedback, meaning more or less that the atomic feedback was a bit more concrete and a bit more elaborated than the classic feedback. So yeah, that's another difference. And you can also make correlation diagrams. The difference between this diagram and this diagram is that these words are correlated. So that means that they appear a lot of time in the same text, so in the same feedback for the same student solution. These are words that really come next to each other. And there you can actually make the same conclusion. The network of atomic feedback is much more dense than the network of classic feedback. So if we would summarize this, we have our 2 bags. If we summarize the similarities, the word usage and word frequencies were almost equal between both conditions, and unequal distributions belonging to bad, moderate, and good answers, but also a lot of differences. Much more feedback given in the atomic feedback condition, limited use of abbreviations, good answers mostly labeled as perfect because the button was there. And also, if you look into these graphs, you will see also a lot of selection titles. So I like first step, last step. These appear much more frequently in atomic feedback than in classic feedback. And then because the networks are more dense, you could say, yeah, normally that instruction is a bit more concrete. I think everyone is now asking, yeah, okay, text mining, that's very nice to use some very statistical methods to look into qualitative data. To save your soul, we actually are at the moment also doing a qualitative analysis. We used the codebook of Bush there to really categorize the feedback. And there are some categories like the diagnostic activity, the focus of the feedback, quality features, and the level of concreteness. These are very, very early results because not all, it's almost done, but not all data is coded already. And there you can indeed see a bit the same. Atomic feedback is more concrete compared to the classic feedback. It addresses some more deficits as well. So some things are not mentioned in classic feedback while they are when the teachers could reuse feedback. Also, some more strengths are addressed. Also, if you look at the diagnostic activity, it's very poor, to be fair. Lots of teachers just describe what they see in a student answer. They don't really analyze what happened and why a student was wrong. But more or less, there it's the same. So also quality feature and comprehensibility and correctness, it's almost the same between both conditions. I'll talk a little 20 minutes, but there will be another demo. So that's actually the whole first study about semi-automated assessment with atomic feedback for individual teachers assessing handwritten math tasks in their classes. Some of the people are actually here. I was contacted by them and I also wanted to contact them to also try, can we also do something with semi-automated assessment when it's not about individual teachers, but when a group of teachers has to assess the same exam, for example. In Flanders,
Do you think maybe since you have finished with the first study, it's a good moment for...
Oh, absolutely.
check
Yeah,
the
yeah.
questions, because
Yeah.
I feel like we're already bumped with a lot of information.
Okay,
and we
no,
need to
no, it's
digest it a
absolutely
little bit.
perfect. Yeah.
Yeah. So if there are any questions, because what are in the chat you have. Yeah, Chris, you are welcome to just speak out.
So Chris Sanguine wrote, in mathematics, feedback is often relates to a specific symbol. What plans do you have to attach feedback to a specific location on the page? So yeah, what actually happens if that the student solutions are scanned in or photographed, they can also, of course, upload it themselves to Moodle. It should be quite easy that a teacher can tap on that picture where the mistake happens and then can start writing the lists of feedback items that really belong to that location. And that would also make feedback more reusable because teachers won't have the urge to say where the where the mistake happened, because then they can just link it to each other.
That's actually very close to the question that I had, and I think that's super great, because indeed we want to show where, but I don't quite get how do you see it more reusable. It seems to me that such a feedback would be much more concrete to the precise student solution rather than generalizable.
Yeah, but of course, the whole idea of writing the feedback in an atomic way would stay the same. I say that because one of the violations of being atomic is actually the most popular violation was that teachers always often said, oh, in the second step, this mistake occurred. But then in one item, there is a location and the actual mistake, making the item less reusable, because of course that mistake can happen to another student on another location. One of the things I already experimented with is that also if you can really point to a mistake, then this can also very informative for the system to suggest items, because mistakes that happen in the beginning of a student's answer will more likely be the same. So that will be easier to suggest relevant items to teachers then.
Thanks. There was also shortly some hand, and then it disappeared. Whether someone.
Well, as we wait for the hand, could you show the last slide before before the next section starts? Could you show that once more?
Definitely. This one.
Yeah, I thought it was interesting, and I didn't have enough time to look at it all.
Sorry. Yeah. But these are very preliminary results because the whole data analysis is not yet finished. We were a bit demotivated by the not so high quality of the feedback. And you have to know the teachers that actually participated in the experiment did that, just they gave up a whole summer day. So we really have the most motivated math teachers of Flanders there. So the fact that almost none of the feedback was really analyzing why a student came up with a certain mistake is rather disappointing. But of course, the experiment was not about learning teachers to formulate feedback. That was one of the things I said immediately. I will learn you how to write to make your feedback more atomic, but I will not learn you how to write good mathematics feedback. That was not the goal of the research.
Thank you. I have many more questions, but I think that since there are no more, let's continue and then again have more.
Perfect. Perfect. So the question now in the second study is, can semi-automated assessment also work in a group of assessors? And there is one specific institution in Flanders that really is in need of it. We have like an exam commission, the Flemish Exam Commission. It's actually an institute where everyone that doesn't will have a degree by a normal school can go to take exams to get a degree of secondary education in Flanders. So, and what they do for mathematics is they organize exams for the different directions we have in our school system, and definitely the advanced math exams are a mixture of digital questions and handwritten questions, and those handwritten questions are scanned and then sent out online to external assessors that have to grade them according to a predefined grading scheme. And those external assessors are actually Flemish teachers, math teachers who want to earn something more mostly, or want to have some more experiments with grading and assessment. So we work together with them. They have 3 exam designers really working for the Flemish Exam Commission, and then 7 external assessors were involved in this experiment. And 60 students effectively took the exam where this experiment is all about. And what was the idea? Like, what an external assessor receives at the moment is this. So they get the students, the scanned in student solution, and then they get a grading scheme with a solution key, and then all the partial grades that should be assigned when a student did something well. And they had some serious doubts also about the inter-rater reliability of what these external assessors were doing. So what actually we did in this experiment, we digitalized the whole correction system and we created something adaptive. And you will see actually that all those items are atomic feedback items as well. I'll show you the system, and then it's also, I will give you a few minutes to go to some questions. So for example, this is a question about complex numbers, a very procedural thing, no problem. So you see the student answer, you see the solution key, and where my system of this, the system of this experiment is all about is what an assessor should do is read all the items and just check the items that hold for the student that you are assessing. So for example, let's say this is completely perfect, which it actually is, then we can say, oh, correct complex conjugate, and then things are happening. Because when this was not clicked, the computer knows that something is wrong with the complex conjugate, but then that's what happened a lot of time in mathematics, follow through marking. Then the correction scheme says, oh, if the complex conjugate in the numerator is miscalculated or not applied, the student's answer will deviate from the solution key, and then it says, therefore, it is necessary to check the student's calculation individually for the indicated item. And then all the items where the student solution can now deviate because the complex conjugate was wrong are indicated, so the assessor know, okay, I really have to check this individually to see if I calculate through with the mistake the student made previously, if what the next steps are valid or not. So no correct complex conjugate, check individually, correctly multiply by the conjugate binomial in the denominator, yes or no. If the complex conjugate, if the blue step was correct, all the orange will disappear, but then because then you know you can just follow the solution key. And by just checking what really holds for the student under consideration, the grade is calculated. And you also see that, for example, you can only give the deep blue and green grades if the purple grade was already selected. And and that makes it actually very adaptive. And so a great, and also feedback for the student, because it's two things. You have, the student will see what is selected for him. I will give you another even more impressive example, in my opinion. That's question 8. It's about space geometry. You have a very big question about the distance between a point and a line. You have also multiple options to solve this question. And then the first thing that the grading scheme actually asks to the assessor is what method was used. And depending on what's selected there, other items are appearing. So it's really like a flow chart that guides you through the whole assessment ID. I maybe give you, you can use the same credentials, give you some minutes, some 2 or 3 minutes. So all the questions of the exam are, if you go back, so if you click on at the course Mathematics Education Seminar, you go back and then you can see all the questions that were in the exam and the adaptive grading scheme that was included.
Sorry, Philip, I'm lost. If I just press on this question 1 on the screen,
Yeah,
you
you
show,
can, yeah,
Then
absolutely.
I see nothing.
But then
Yeah,
the whole
somehow...
system collapse if you say question was left blank by the student. So if you unselect it, you will see the whole thing.
No, but I don't even see what you see now.
Oh, that's sad.
But maybe it's only my problem. I don't know.
Maybe you have to click on grade indeed. So if you click question 1, then you have this, and then
Do
if you
also see this? So if I do study and then I have question, I have one. Okay, Michiel, help me.
perfect, perfect. I will give you 1 more minute. Definitely check out question 8. I think that's the question we are most proud of, because that's the most impressive question. And all the guidelines that are in it to correct a certain exam are actually completely automized. That's the whole idea behind it. So I will start talking again. So the goal with this checkbox grading thing is to ensure that all assessors do the same thing. They just have to follow all the items from top to bottom and select what applies to a student's solution or not. But also, and that was one of the other things we wanted to achieve, if students now take part in an exam of the Fleming's Exam Commission, they only get their grades and the grading scheme, but they don't know how the grades was obtained from the grading scheme. Also, the exam designers, they don't always know how an assessor really came up with a certain grade. By this system, yeah, this becomes very transparent, and also you have feedback for students. They really know how the grade was obtained, but also the exam designers can see, okay, the assessor did this. Now they don't really know. An assessor only communicates based on the grading scheme, the grade, but nothing more. So up to you, we've done that. So the whole idea about this experiment was 60 students actually just did a very normal exam in the exam commission, but what changed for them was that it was assessed the handwritten questions with the system I just showed you. And we also, when all the assessments were done by all the assessors, we also send out the students a survey to know how they like the feedback they are receiving from the system. And then also to know if this system is more reliable than the traditional system with the grading scheme and just communicating a grade. Is more or less reliable than the checkbox grading approach that I just demonstrated to you. All the assessors had to redo all their corrections 5 months after the experiment with my system. So why 5 months? That they forget what they did with all these students 5 months earlier. And every assessor had 30 students in common. So 30 students were, without assessors really knowing, were assessed by all the assessors. So yeah, time difference, that's the goal of my PhD. Is there a time differences in when using my system or not? Is my system more reliable, yes or no? And how students understand the feedback. One of the things, if you look carefully, what you also can do is, if you use the demo of today, then yeah, you click and you also see the partial grades that are attached to items. In the real experiment, we did something even more nice. Half of the questions an assessor had to assess didn't have any reference to a grade. So they saw this, but without the grades. So they just had to select everything that applied to a student solution. The computer calculated the grade, but they didn't know how the computer was calculating it. Why? Because we know from research of rubrics that a lot of teachers will choose other criteria when the final grade is not in line with what they would give if they would assess it in general. So to see if there would be a difference between blind grading, where they just had to select the appropriate items without reference to the grade, and then the other condition where they really could see how the grade was obtained is then the visible condition. Again, no, my system wasn't better in terms of time. Even on the contrary, traditional grading, so the thing, the time for each exam 5 months after the experiment with my system was almost half. So with my system, it took them 5 minutes approximately to grade an exam. With the normal system, it's only a bit more than 2 minutes. So my system actually doubles the length of assessment time. Then there is a huge, but I'm not going to detail about that. I made a huge side bet for my PhD to find a measure to really calculate the inter-rater reliability. I'm not going to detail about that. if you want, you can write a preprint that will come out soon about the measure, but let's keep everyone happy today. What comes out if we compare the inter-rate reliability between blind grading and visible grading is that indeed for some questions blind grading is much more reliable than visible grading. Definitely for question 3 it was the case. It's not so outspoken. We couldn't find significance for all the questions, absolutely not. Also, if you take the exam in general, we also don't find a significant difference. And definitely question 3 is very interesting because the grading scheme that was designed by the exam commission was very strict there. So assessors had no clue what it actually did with the student grades. So they just went along with the grading system. They didn't do that when they saw, oh, this really penalizes the student in a very hard way, so I will deviate from the grading scheme. So that partly explains the difference here.
Filip,
Yes,
just one clarifying question. So
please.
is the difference between blind and visible simply the thing you just discussed, whether they can
Yes.
see how much points is
Yeah.
is connected to the checkbox?
Yeah, indeed. And also in the blind condition, they also didn't know the total grade on a question. They couldn't see anything about grades in the blind condition.
And here you compare two indexes of inter-rate reliability.
Yes.
So
yes.
you show if they did, and this is not like, for example, if I feel that system is too cruel to my student, I might want to adjust it in a different positions. Then the inter-rate reliability immediately drops, which
Yes.
doesn't mean that I'm doing bad thing.
Oh, that's a very philosophical question. Of course, in the exam commission, it's very important that the chances for each students are equal. But what somehow relates to what you're saying, and that's very important in the whole experiment, these exams are assessed by external assessors that totally don't know the students. So they really don't know who these students are. Actually, I think if you do the same experiment with teachers assessing their own students, I think blind grading will be much more reliable than visible grading because yeah, there you also make some assumptions on how the students behave, halo effect and stuff like that.
No, but sorry, that's maybe a technical detail, but what I am trying to say that if you here, instead of comparing reliability indexes, would compare the standard deviation between the graders, it could be the different result because all the graders could together decide to cheat the system a little bit because the system is not good. And
Yes.
then, although they would cheat in different places, the general score and the standard deviation of the score would still be narrow.
That's true, but this index also takes into account really the feedback item you clicked. So the kappa that's shown here takes into account the deviation of the scores, but also which feedbacks
Exactly.
were clicked. Then the assessors assessed the exam using this system. 5 months later, they redid it, the whole thing, but then in the classical way. They got the grading scheme on paper from the exam commission and they were just asked to communicate the grades. Of course, I hoped that my system would beat the traditional grading system, but it didn't. Actually, there are almost no significant differences between the questions graded in the traditional way or using this system. Of course, the difference is that my system returns a lot of feedback for the students as well. I'll skip this to give some 15 minutes for discussion as well. I asked us already, I also asked the assessors with the TEM model what they liked about the system. they liked visible grading much more than blind grading. In terms of anxiety, they are much more anxious about blind grading because, yeah, they don't have any reference point anymore. Then they don't know what they clicked, what it actually returns. So if you, yeah, let the assessor decide, they would definitely go for visible grading. And then that's actually my last slide. The students like the feedback very much, and definitely it would be great if the examination commission always give this type of feedback. So surveys were sent out to all the students with some of their feedback on the exam included. We also interviewed some students. These data are not yet analyzed. What's very apparent in the whole student story is that good students tend to understand the feedback they receive very well. Bad students who would actually benefit from the feedback most don't always understand the feedback that come out of the system. So one of the things we did in the interviews was I gave them their assessed question, and I asked, can you now say how the grade was obtained? And they saw the items that were checked for them. Some students really failed to see what really went wrong in their answers. So that was what I had to say. So there is some room for discussion, and I think I talked exactly 1 hour, demos included.
Thank you, Filip. Wonderful flow of information, a lot to think about. And indeed, thank you for giving us some room for discussion and questions, please. So now we have also seen the student perspective, which
I could ask a general point for discussion, I think, would be this general question, like, to what extent is feedback, is it possible to what's your opinion on this? Is it possible to standardize feedback like this for all students the same? And to what extent, I think it's really interesting to let me be clear, I think it's wonderful what you're doing, and I think it's really interesting to research this. But do you think there are limits to the amount that you can standardize feedback? So if you like this, or should it be more personal for each student?
If we look at the first study, I think one of the definitely strengths of the approach that was presented is that you can still make your feedback very personal. If there is some method used by a student that was not used by any other student, you can still write atomic feedback items, especially for that student. And when in the future another student would use the same method, you can maybe reuse it. But I think definitely one of the strengths, definitely compared to fully automated systems, is that it can still be quite personal. Of course, the second study, it's not really possible. It would also not be achievable in terms of money to really give personalized feedback to all these students.
Yeah, you're right. The first system really allows that still in a very nice way, that you, if you want to just give a bit of pep talk to one of your students,
Absolutely,
you can still do it, and
absolutely,
and reuse it if you
and
want.
reuse it.
Yeah. All right, that's true. Yeah, and then the second one is really more of this, if you grand scale, big central exams, and you still want to have this,
Yeah,
this workflow. Yes.
comments maybe. Yes, Paul, please go ahead. Paul?
Hi. Hey, Filip, can you hear me?
we can hear you.
Good. Thanks for your nice talk. I was wondering a bit to zoom out on your methods. I was wondering your atomic feedback and the hierarchy in it. Of course, this is not fully automated, but semi-automated. But if you really think of the work by Johan Juring and Bastiaan Heren and Sietske Takuma, and so they use these domain reasoners, which essentially are lists of rules and buggy rules, also hierarchically. This is also implemented in the digital math environment. And of course, this is fully automated rather than semi. But the essential idea of having these type of hierarchies of rules and buggy rules, to me, seems quite similar to what you are doing. Did you look into that, and what's your opinion on that?
Yeah, I had a look into that. Definitely when we rewrote the proposal a couple of years ago. Actually, it's somehow inspired by that as well. Actually, the idea of reusing feedback was already in the proposal of the PhD project. But then I was like, yeah, but actually, if you just write feedback, it's not so it's absolutely not so reusable. I showed you the example of the whole text a teacher wrote to a student. And then I was like, okay, maybe we can break it into parts. And then if you think about it further, maybe a hierarchy can also help. And that's, how we came up with atomic feedback. But it's definitely inspired by things we also saw by, for example, I think you also were involved with a project of assessing a proof, like a metric automatically. It's that where you are referring to, no?
No, it's more to a project called Advise Me, and also Sietske Takuma's PhD, which, it's a quite specific approach by Bastiaan Heren and Johan Juring. It's called domain reasoners, but okay. Apparently, you're not completely able to compare their work to yours.
I will have a look into it.
Yeah. If I may continue, I have another small question. On one of your first slides, you mentioned something like misconceptions and systematic mistakes, if I'm not mistaken. I think it was maybe, but this was a bit surprising to me, because I thought, maybe it was one earlier, or is there no earlier?
This one?
I don't think so. I think you mentioned systematic and misconceptions on one slide.
Yeah,
it was
here.
relatively early.
Yeah.
Yes. Oh, sorry, structural or misconceptions. But do you see that as two different categories?
No. No, but structural misconception and mistake is more. It's easier to talk to teachers about a structural mistake because everyone knows, it's a mistake that happens a lot of time. For example, making the denominators not the same. A misconception, I see it more like some real conceptual problem that's in the student's mind.
Okay. Okay. And if a student just has a kind of slip of the pen and makes an incidental error, how would you call that?
Just an error, no?
Yeah. Okay.
Yeah.
So, but, no, that makes sense. But I thought you were like, so the or here means not that they are completely different.
No.
Okay, I thought you were opposing the two. Okay, thank you.
Okay, then we have Rohir and then Michiel.
Your current research, you said it's about quality of feedback. And I think that's really a very important point that is hovering above all discussion today. So could we go back to that slide, and can you tell us again, how do you assess the quality of feedback? How is it going to play a role?
So I used the code book of Bush, Julia Bush was a PhD student at the Institute of Bärbel, and she actually organized professional teacher training to improve the feedbacks teachers were giving. And she had some nice results in her PhD thesis, but she had a nice code book to classify feedback in mathematics as well. So actually what she does, she say, okay, what's the concreteness level of feedback? Is it general or concrete? General is like, oh, you did it very well, or you made a mistake in the last step. That's very general. Concrete is that you really point out to what's happening in a student solution. Yeah, the focus of the feedback is the amount of strengths and deficits that are addressed. And then the diagnostic activity, what she says analyzes is really like in the feedback of the teacher, it is apparent that the teacher really thought in the mind of the student, like what made the mistake occur. So for example, in the word problem, the choice of the unknown is perfect, but you didn't adjust it for the grades very well. That's kind of analyzing. So seeing how the mistake happened and reporting that to a student is analysis. Description is just saying what's wrong in a student solution, not really explaining why it's wrong, just saying a mistake in the first step. And then correction is also when you give the right answer, what it should be. And then if you look at the results, very few, but very, very few feedback is on the level of analysis. Almost none, actually. 3% in atomic feedback, it's very, very low.
Yeah, that's very nice. I would just one last remark, and maybe you should definitely go on to Michiel and other questions. But to me, it's also whether feedback is on the strategy the student has followed. Like that would definitely improve the quality, not just saying, hey, there's a mistake, the 3 should have been a 5, because I don't really care about those mistakes too much. I care about whether the student has made a plan before it attacked the problem and whether I can see that. That sort of thing is maybe not yet really in this analysis, or is it?
Actually, it is. That's what I will. The part of the code book is already written out. I will send you it after the meeting. That's actually what analysis is all about. So diagnostic activity analysis is really, looking into the strategy a student took and reasoning with the students. And that's not what description and correction is about. But we see it very often appearing. It's kind of demotivating if you code all these things. We did a lot of iterations, of course, as well to get to code the same, but it's somehow a bit depressing. Like, the quality of the feedback is quite low, I have to confess.
Yeah, okay, it must be about time as well. I'm sure this teacher could do it if they sit down and take time. But anyway, let's move on to other people's questions. I don't want to.
Yeah, thank you, Philip, for the nice presentation, and also very much appreciated that you let us have a glimpse at the system. That is really helpful also to understand what happened and what it is all about. Yeah, my question is also a bit related to this table. Maybe I missed it, but did you also analyze how the teachers, while being involved in this process, how their giving feedback improved? Because they reflected also, of course, on these different categories. Or did they also see this overview to reflect on the quality of their feedback on the different aspects that you can give feedback on and how you grade it? Because what is a big mistake for the one is a small mistake for another, and so this is a nice opportunity to discuss all that with each other.
That's true, but no, the teachers there were some teachers present today, but I always send when something is published to them. So, and I will communicate this table definitely when the whole analysis is finished. But the focus of the experiment was really how do the teachers, in our context in Flanders, behave when using both systems, classic feedback or reusable feedback, by writing it by using our system, and see what happens. We also didn't train them in giving feedback. I'm definitely sure if I would give an introductory course about misconception that could appear when solving linear equations, we would see much more misconception addressed, but that was not the goal of the research. It was just to see if we could learn teachers to write atomic feedback that was achieved very easily, and then see what they do with it, not to change what they're doing actually.
No.
But actually, Julia's work, sadly, it's mostly in German, but Julia's work, where I'm referring to, goes exactly about that. So can we improve the feedback skills of teachers after some very well carefully designed professional training? And she was able to improve the feedback skills of teachers quite heavily, actually.
Yeah. Okay. Yeah. Thank you. Clear.
Thank you, Philip. I also have a question related to this teacher development skills. And what I study quite a bit is joint attention. So the joint attention is a mechanism where I, together with the students, sit somewhere and we together understand what's going on. So my question goes like this: if good teaching is about getting what student is doing and somehow helping the student to get exactly at that moment together, isn't this system actually moves the teacher away from this goal? Because this system forces a teacher to give a generalizable feedback, not the feedback which is pointy for the student. So that's what I'm concerned with. And just a small bit, particularly with your final result, that students who achieve not so good as others, they don't quite benefit from the feedback. And I think that's even multiplied by this atomic feedback, because it's even more difficult to comprehend when it's given in a general way.
Yeah, I totally understand your question. Of course, definitely in study one, the atomic feedback could be as personalized as normal feedback, so I don't really see a problem there. Also, if you teach big classes, it's often not really achievable to talk to every individual student. I think providing some feedback is already something, and not just communicating grades, which is very, in the Flemish tradition, very common. One of the things why I keep on repeating these are preliminary results is one of the hypotheses we had. We also, to really establish the code book of Julia and to really, with the second coder, have the same ideas about every code. One of the things we had with some pre-study data is that there was much more erroneous feedback, so this category, in the atomic feedback condition than in the classic feedback condition. And we hypothesized that's because it's so easy to reuse items that sometimes teachers just click items that they think, oh yeah, maybe this can be nice for the student as well. While if you really look at it again, you say, hey, why are you noticing that? It doesn't. But for the moment, the preliminary results don't. Yeah, the percentages are completely the same. But maybe if the full data set is coded, there can be a difference where I expect more errors in the atomic feedback condition than in the classic feedback condition.
And actually, I think that at the end, you exactly explained why this system pushes the teacher to give general feedback, because it's constructed this way, right? Maybe you could think of a kind of two-step procedure, right? A very short, like, here's a problem, or great, you did nice, well, here. I also find it difficult that emotional feedback is somehow gone. But while that's is known, like with the scaffolding, for example, motivational scaffolding is important, right? So that the teacher really pushed to get into the student. and only then give some
Yeah.
possible. Thanks, Rohir. I think that I give word to you to say some final words, actually, rather than to question.
So
famous
I think
final words.
Sepnum's question, I think I addressed it when talking about feedback quality and
Yes, I have my answer. Yeah, it
okay.
was just answered after I typed it. Thank you.
Perfect.
Oh, sorry, I didn't attend to chat. Sorry. Yes, thank you.
So yes, just to try and end in time, I want to thank you very much, Filip, for your contribution today. It was super interesting and clearly sparked a lot of interest and discussion. As for me, I'd love to discuss a bit more, so maybe you could stay a few minutes after this official closing, but please don't go, people, before I've announced next month, because I see some new faces, and actually this seminar is every month, with each time another very interesting speaker. So next month we've got a Dutch speaker again, and her name is, ouch, her name is, I make this a little bit exciting, building up tension. It is Sanne Willems, and she's going to talk about statistics, communication, I would say, a bit more general than just education, but also misconceptions about statistics. So you're all very welcome. If you want to
Yes, still sharing screen.
stay up to date, then you could actually subscribe to our email list, and we'll just invite you.
Thank you, and thank you, Filip, once again. We can also stay together a little bit, chat afterwards.
Perfect.
Yeah. So my other question,